Okay, I just want to do a few more examples of transposition. We'll look at this first equation. T equals 2 pi root 1 over g, which is the swing of a pendulum. And we'll transpose this for g. Now remember in reverse BIDMAS we go 1 divided by g, square root, and then 2 pi times by 2 pi. So we'll do it in reverse order. We'll move the 2 pi first. T divided by 2 pi. We do that on both sides, so that eliminates it from this side. And the next thing to get rid of is the square root. So to get rid of the square root this side, we need to square. So what we do to one side, we must do to the other. Now once you get to this system, we've found 1 over g. We actually want g. And if you've got this situation where you've got a fraction here, even though it's in a square bracket, we can simply invert the fraction. So it becomes 2 pi over t squared equals g. So that's a neat little feature. Sometimes you just have to invert fractions. Okay, let's try another one then. So we've got this one now, which is, you might recognise this from mechanics. This is distance equals initial speed times the time plus a half the acceleration times the time squared. And we'll transpose this for the acceleration a. So I think you can see the first thing we do is we move ut. So ut is add in, so we take it away from both sides. Now usually what I do is I show that as a t squared over 2, but I'll just show it works if we look at it as a half multiplying this. So if it's multiplying, we divide both sides by half. So let's do that. And if you remember your rules from fractions, then to divide by a half you turn it upside down and multiply. So that's why that becomes 2s minus ut equals a t squared. And finally we'll get rid of the t squared, it's multiplying a, so we divide both sides by that. So a becomes 2s minus ut over t squared. And I think we'll leave it like that. We could actually break that up into two fractions, a piece here and a piece here, and then cancel that t out. But that's good enough. We'll leave it like that. Okay, we've got this example now. And can't really use reverse BIDMAS on this because we've got an x there and x there. So what are we going to say? We can't say x plus 1 because we've got x plus 1 there. The idea is to get all the x's on one side of the equation. So that's the first thing we try and do. And all the rule you really need to follow is that what you do to one side you must do to the other. So let's expand this bracket first of all. So that gives us 2yx plus y equals x plus 1. Now we want to get all the x's on one side, so we'll move this y to this side and we'll bring the x this side. See what we get. So we've got 2yx and we'll bring in the x over. Well, the x is, that's positive x, so bring it to this side, it's minus x. Remembering we're really taking x away from both sides, but sometimes you can get to think of it as going to the other side and doing the opposite. And that y, it's adding this side, so we take it to the other side, call it minus y plus 1. We've got a common factor of x, so we take the common factor out. And I'll turn that, put that around this way, just look a bit neater. And then finally, this 2y minus 1 is multiplying x. So all we need to do is divide both sides by 2y minus 1. And that's that one done. We've transposed it for x. So this happens sometimes. You've got to sort of expand things out and move them around. But the key thing is what you do to one side you must do to the other. Okay, let's transpose this one for x. So we've got x minus c on the bottom, so let's get rid of that first. We need to multiply both sides by x minus c, so that gives us y, x minus c equals x minus d. Expand this out, so and keep it in alphabetical order, xy minus cy equals x minus d. Bring all the x's one side, so that's a positive x, so if we take x from both sides that gives us xy minus cy minus x equals minus d. And now we've got this minus cy, we'll get rid of that by adding cy to both sides, so that leaves us xy minus x equals cy minus d. We've got a common factor here in x, so take the x out, y minus 1 equals cy minus d. And finally we divide by this bracket here because it's multiplying x. We divide by y minus 1 both sides, and that will give us x equals cy minus d over y minus 1. And that's that one done. We'll just do a couple more. Suppose we've got this formula and we need to transpose it for v. So we end up with v equals something. Well, let's get rid of 1 over u from both sides. So it's adding to this, so we'll take it away from both sides. That leaves us 1 over f minus 1 over u. I think this is a sort of lens formula. It's 1 over v. And now we make this a common denominator. So if we multiply these together, f u, and if you look at it, we've multiplied the f by u, so we need to put a u there. And we multiplied the u by f there, so it's minus f equals 1 over v. And just like we did in an earlier example, we can just invert this fraction. So v equals f u over u minus f. And that's that one done. Our final one is y equals x over x plus y plus 2, and we'll transpose this for x. Of course we've got x top and bottom, so you can't do reverse BIDMAS. We just have to play around with the equation, try and get x on its own. I think the first one we do is multiply both sides by x plus y. So that gives us y, x plus y equals x, because we got rid of it from there. But we must multiply this by x plus y, because we've multiplied the whole equation by x plus y. We'll expand this and expand that and see what we get. And put them in alphabetical order, so xy plus y squared equals x plus 2x plus 2y. And what we'll do now is bring all the x's one side and all the y's the other. So we'll take 2y from both sides and we'll take xy from both sides. So that gives us y squared minus 2y, and I can add this together, x plus 2x is going to be 3x minus xy. Okay, we've got some common factors here. There's a common factor of x, so let's take that out. So we've got y squared minus 2y equals x 3 minus y, and then finally we can divide both sides by 3 minus y, so we'll end up with y squared minus 2y over 3 minus y equals x. Done.